You're good.
Good? Okay. So come closer.
Do you need me to?
No, I believe she said, yeah, this way.
Normally I turn off these lights here.
Yeah, yes, I can. Yeah, that's good.
See,
I hope the camera can still see you.
what?
I hope the recording still looks good.
I think it'll actually look better
Oh, okay.
because the brightness of the screen.
Okay, guys, let's pray and then we can start, okay? Our Heavenly Father, thank you very much for this beautiful day that you given us, God. And God, we're just thanking you for these kids. We're thanking you that you are doing the work in their life, God. And God, they are at this fork that sometimes we don't know which way to go and what's upcoming in next in our life, God. God, we are putting them in your hand. We are asking that you guide them, their path, God. Show them your will in their life, God. And God, this little presentation that I put it together for them, just to them to see that what the electrical engineering do and what's the upcoming scope and everything for this profession, God. God, we are putting everything in your hand, and we're just asking one thing, that your will be done in all our life, God. All this we ask in Jesus Christ's name. So this is, I work for FirstEnergy and I'm a program manager now, but my background is in electrical engineering, and that's why I came up from studying electrical engineering, being my Bachelor of Engineering in India, and then I did my Master in NYU here. I also have two certifications. One is engineering side, it's called Professional Engineering Certification, which required for you to sign any legal document that you need one, which I never signed it, but I have it, that license. And then I also have license in project management, it's called PMP, Project Management Professional, which I decided to take later on in my life. I just passed it 2 years ago because I'm in management field now. So even though I'm in engineering, I thought that it was better for me to get the license. So this is about electrical engineering. I put some of my project that I work on it at the back of this presentation. So we're going to just go through like what electrical engineering do, what kind of different field you guys can go to, and what each field has, little description about it. So what is electrical engineering? So electrical engineering is a branch of engineering science that studies the electricity. So when you call about electricity, it's generation, it has to generate somewhere, right? Generation, then usually the power plant, what we call, you don't see it here. It's way far. We have one nuclear in, I think, Salem in South New Jersey. And then that power needs to be transferred from that location to here. And its wording is very easy. But when you put it to perspective and the work that goes behind it, it's like years and years of infrastructure we are talking about. So it's generation, the second part is transmission. You take the generation and transmit. And then the third one is distribution, which here, after the transmission, is distributed to whoever wants it. That's called distribution. It's three major, when power engineering, electrical engineering come, right? And then its application, how you're going to, motor is going to run and all that different stuff. So the branch that studies electrical engineering. So this is just a little bit power grid I put it in. That's the power generation station. It's right over there. It could be nuclear or hydro or coal generation, whatever it is. And then this is called power transformer. It step up the voltage that generate the power. And then this is the big transmission line that you guys can see. I think US one has those big transmission line too. And then you come to your transmission substation. This one step up the power, voltage. I wouldn't say power, voltage. This one step down the voltage. And then you put it on your local transmission, like sub-transmission, sometimes we call sub-transmission distribution, and then it goes to the distribution. Usually we have smaller transformer that step down the power one more time if we are supplying to the residential customer. Commercial customer usually take power from sub-transmission because they need a higher voltage and more power. So that's just little thing, whole power infrastructure that I put it in together. I work in power, so I put it in power, but there is a lot of other branches that you guys can consider too. So what the electrical engineering discipline? So there was a 3 core discipline. We call it core because from that everything branch out. It's called electrical, mechanical, and civil. Regardless what you take, computer or IT, even architecture is branch of civil engineering. So the electrical is one of the core engineering form. And then there's you can count a little bit more if you want to really think how you can put robotics here. But this is the main 8 branches that actually separate from electrical: power, signal processing, microelectronics, electronics, control, telecommunication, computer, and instrumentation. So some electrical engineer could be working in, like for me, is power. Some could be working in computer, or some could be doing something with the electronics or telecommunication. So what's the power deals with? The power deals with generation, transmission, and distribution. We just went over it, of electricity, as well as device including transformer, electrical generation, motor, high voltage devices. So that's just the power branch of the electrical engineering. Signal processing. Signal processing deals with the analysis and manipulation of the digital and analog signal. So anytime you send the signal out, how that signal is going to process. It could be on computer side, or it could be, we used to have that wired phone, that analog phone. We don't have that anymore, but we all have digital stuff. But it could be analog signal or digital signal that they're processing. The third one is microelectronics. So microelectronics deals with the design and fabrication of very small electronic circuit component for use in an integrated circuit. So integrated circuit has very small component. If you sometime open up the computer or something, you'll see this very little component that's soldered together with each other. That's microelectronics that deal with them, and how put it together, how they're going to function, and all the different stuff. The fourth one is electronics, and it deals with the design and testing of the electronic circuit. The user uses resistor, capacitor, induction, diode, and transistor. This is different. I don't want to go in detail, but different part of the electrical component. And then most of the electronic circuit are use characteristics of those components to build the electronics devices. And control. I think last time we had a stand, there was a control engineer was with me, I forgot his name. But the control is what they did, a focus on modeling of the device and dynamic system to achieve something that you want to achieve. It's like our heating system is a control. You put in 74, and some houses are very smart that can heat it up, and 74 is the desired temperature. Depends on the outside temperature, inside temperature. It can turn on the heat, or it can turn on the air condition, and keep your house at 74 or whatever setting you put it in. That's control. Your desired thing is, I want 74 degree in my house. But there's the system that goes behind it. It's called control. There's an input that it takes, and then that gives out the output, and then you achieve your desired output. The next one is telecommunication. It focuses on the transmission of the information across the channel, such as coax, cable, optical fiber, or free space. Fiber and free space are very big right now. Fiber communication and wireless communication. I had a certification in wireless communication from NYU. I never pursued that route, but it's very big thing right now, especially with this cellular thing going on, and Verizon has a lot of fiber network too. A lot of opportunity on those fields too. Computer, everybody known designing computer system and hardware. Computer is part of the electrical engineering too. And the last but not least, instrumentation, and it's design of the device that measure physical quantity, such as the pressure, flow, and temperature. And that's why it's called instrumentation. And you need, especially in this branch, you need a lot of physics too. You need to know, because it all deals with physics and how to develop the instrumentation behind it. So now, how to become electrical engineer? So high school, consider taking accelerated courses in math and say you need math and science. There is no other way when you want to become engineering. So math and science, study hard for SAT and ACT, and look into the college earlier, right? You wanted to know, I wanted to go in this college, or this college is a really good program that I would like to go. It's better look into it and then apply for it and have a choice at the end of the day. Then I want to go here, okay, I want to go here. 3 different places will give you the offer, then you have a choice, right? Which one to pick. So it's always look into the college earlier and see which colleges are good in what. College, study hard. I remember studying in my college. Engineering is going to be hard work. It's not very easy. 1, 2, 3. And I would say none of the study, any of the college where you go, you gotta work hard. But if you trying to pursue study further, like you want to go master degree, most of the college require 3.5 GPA in undergrad for you to go and master. If you become a doctor or go to PhD, 3.5 GPA in your master for you to even pursue your dream. So you have to work hard, because in your own end of the college you might say, hey, I want to go for my master, or I want to become professor, right? But if you don't have 3.5 GPA, then what are you going to do? Because most of the college require it. So internship, I would say it's must. When you are in later year of the college, that's how you go into the industry. I got my first job through the New York City as an internship. I went into as an intern, and then I got offered a job right after my internship. So if you can get in your focus industry that I want to to work with these people, go look for the internship and just go for it. And then design project is big too, especially when I was in my master, because lot of industry look for it. If you did a design in specific field, or like say fiber, it did something, and Verizon look into it and say, hey, this guy did really good job, in this project he did. Why don't we bring him in and just take his interview? Maybe he's good fit for this opening position. So I think the design project is very important too. Post-college, you have like 3 basic options that you can go through. You can go to the next step, become towards the PhD and become professor, or you can get your PE license. PE license is 2 steps. You have to take your FE exam first. As soon as you come out of the college, take a 4 years experience and then go for a license, a professional engineering license. But if that I would recommend, if you want to go and specially design for. I wanted to be designer of electrical. You need that to design and sign on the document. And the third one, which I am in right now, which is project management. So for you want to go project management and you are already in project management like field, or you're interested in it, look for your PMP certification. And it's not now, but it's something to keep back in your mind that, hey, I wanted to do this. So why considering E, right? Like why you guys wanted to do? So we have to look at growth of where the electrical industry is going, because if it's going down, you don't want to go in the field that's going down, right? You want to go to something that has a future in it. So E is one of the, as we talk about, core field, and its scope, you don't want to go anywhere. You need power regardless of what you do. You need electricity regardless of what you do. So its scope is solid scope. Everybody's going to need the electrical engineer. Everybody has to run the power plant. Somebody has to transmit. Somebody has to distribute. So that's the scope. And I always call it the heart of whole engineering, because you're going to have building, you're going to have mechanical stuff, but if there's no electricity, you're going to do anything. And there's a new market that's coming. It's an EV car. It's big right now. Renewable energy, solar energy, wind energy. I'm working, my company, I'm not part of it. It's called offshore wind. New Jersey BPU pumping out trillions of dollars right now to build a power plant, wind power plant on a Atlantic side, South Jersey. So a lot of money government is pouring into the renewable energy. That's the statistics from Bureau of Labor statistic, and the median salary, American median, is like $104,000 per year, right? So half people making less than that, half people making is more than that, but the median that usually people look when they look any trade is like around 6 figure already. Is you need a bachelor degree, that's the number of jobs, 300,000 job already out there in 2022. And this job, it's only the job that electrical engineering. So I don't consider this job because my title is project manager, right? So when the Bureau of Labor and Statistics look into it, they don't consider me electrical engineering, even though I'm electrical engineer. So those people hold the title something with electrical engineering, like electrical engineer design or electrical engineer or something. That's 300,000. There is a lot of other jobs in management side that you can do. And this is very interesting. the 5% faster than average. So the average growth for any industry is 3%, except electrical engineering. It is a 5% growth in next 10 years, which consider very high when it comes to the any industry. And that's this outlook is saying this, they're adding almost 16,000 jobs every year in electrical engineering. So this is possible job, and you can, this list can go on and on and on, but there's a couple of jobs that, design engineer, you could be electrical facilities, maintenance engineer, engineering professor, power system engineer, power plant engineer, test engineer, project manager like me, or communication engineer, and goes on and on and on. Lot of industry has a lot of different title within the electrical engineering too. My former title when I started, it was a associate project manager, even though I was design engineer. So there's some project that I work on. There's the New York City Transit signal system. If you take an F train, I don't know how often you go to New York. So if you take an F train that's between Smith and Knight and Church Avenue, there's a 5 different stations. The signal system was designed by me for this whole thing. And when I finished designing, I went to the construction. So I used to walk on those track. It's lot of logic goes behind it, lot of cables goes behind it, tons of cable that goes back and forth up there, and lot of logic. It's amazing how I used to think like, oh, it's a signal, it goes green and red, and it's lot of thing goes behind it, where the next train is, where the train behind is, where am I standing right now, and all the logic and the processing goes behind the signal system. There's the signal control tower. So somebody's sitting there controlling all the movement of the train through this little knob here and there. They press it, they pull it, they switch it, and that little knob actually does so much stuff on a track. It can move the switch, it can turn the signal, and a lot of somebody's watching that. And that was part of my project too. It's a train control system that I was part of it. That was a very interesting one. This is the, if you go in 7 train line, and if you use this sign, that was my contract. I was a resident engineer in this whole 7 train line on all 21 stations. And I put it there, well, not me, but me and my team put it together, this sign, next to an arrival sign. And we put it, customer information, the speaker system inside the station too. And this one required a lot of logic too. It's a lot of communication goes behind it between train, all the trains in the system, and the system itself. That's the one that I worked with the New Jersey Turnpike Authority. And I did a lot of work with them but then highway lighting was, we were big on it, because when I took it over, the lighting was doing the bad in New Jersey Turnpike and Garden State Parkway. So 3 years I worked in a lot of lighting projects. The Intersection 9 on a Turnpike, we put lighting to 8, 9, lot of other stuff. So there was, and it's very interesting when you go into the system and see like, it's not like 1, 2, 3, it's a lot of problem solving. And that's the one that I work right now. It's a power station, it's a substation, step down substation that my group, whole group, you work. And when we take a power from this big transmission line, we bring it to the substation and we step it down and we distribute it, or depends on sub-transmission or distribution. And this is all start with the growth of, I handle Eastern Pennsylvania and New Jersey. So when developer comes, or when we see that, okay, this thing or this area will need this many megawatt in the next 5 years, my planning engineer start planning, and then it comes to my desk to figure out how we're going to do this, buy new land and put a new one in, or maybe upgrade something in existing one, and that's what I do right now. Questions?
For college.
Yeah.
Are you supposed to, like, for this stuff, like EE, is there like anything in specific that like you should know before going?
For PE?
Yeah, no, EE, electrical engineering. Like, is there anything you're supposed to know beforehand, like specific?
Well, see, See, electrical engineering is a skill, right?
Well, yeah, I mean like in terms of like whatever you're going into, like electronics, like say for example, what if I was supposed to, is there anything I'm supposed to know for like computer in specific?
No, because you're gonna have core courses, right?
Yeah.
So what usually, if it's changed right now, I don't know, but what usually happen is the first year you take your core courses. So when you take the core courses, it's everything. You want a little bit power, you want a little bit of computer, you want a little bit of electronics. Because most of the kids that's going into college, you might don't have an idea that you want to go in power, right? Or you might not like computer, how do you know? So the first year of your college, they're going to give you core courses. You have to take these core courses, right? And then depends on the core courses, then you would decide, okay, maybe I like this or this is the path that I want to take. But they require you that you graduate from the school with a good grade, and it put you to the different college. You have to submit the application and they'll accept you, depends upon your current state, right? And then once you're in, then they'll guide you, like, okay, this is the core courses. If you're an electrical stream, you gotta finish these courses. And I'm sure they allow you to change it too. If you just finish 6 months and you figure out, oh, I like mechanical more than electrical, and first 6 months, I think most of the engineering firm has almost similar kind of core courses. So as long as you meet the requirement, they would allow you to change it. I studied in my first semester, I studied civil, mechanical, electronics, computer, electrical engineering, and project management. So in first semester in India, we had like everything. And then after first semester, if you do really good, they would allow you to change it. I remember my friend went from electrical engineering to electronics, and 2 of them went to mechanical. I didn't want to go anywhere. So I continued electrical engineering part. But they would give you everything. So it's not like, oh, do I need to have a computer background or do I need to know anything about this? You just do your work hard in your high school, and then when you go there, they'll give you everything. Yeah.
So for your subway projects, like how long would it usually take you, and how much time, how much work do you put into it?
So how much time it takes is depending on the contract, right? If contract is small, work is small, it could take 1 year. My one project was 3-year design that I did and 5-year construction. So it was total 7 year of project. But nobody is telling you to stay there for 7 years. If you're in for 5 years and you find something really good that you want to go in, nobody gonna hold your neck and say, no, you gotta stay here for another 3 years because you got the project, right? So it all depends upon the project. It all depends upon how small or big is the project is. Yeah.
So I'm saying about the F line, how long did that take?
Yeah, that was the project I'm talking about, 7 years. It was 5-year construction and then 3-year design, or 8 year, right? 8 year almost. Yeah, so it was 8-year project. I left it actually, I didn't finish the project. I left it when I was in construction, was 3 or 4 years in. And then I got I got a job in MTA too, but somebody needed something and they just asked me, okay, I'll come work for you. So I left that project before it got completed. Anything else? Yeah.
So you mentioned the thing about the highway lighting system.
Yeah.
What sort of stuff went into that?
What, sorry?
What sort of things went into that process?
So for the highway lighting, the biggest thing is power, right? Those when you put hundreds of lighting there, like one light can operate in little power, but when you talk about hundreds of lighting, it's needed a lot of power. So where to take a power from, right? And then a lot of lighting are existing lighting. Cable runs underground. So when cable runs underground, a lot of underground work needed to do. So it's a lot of stuff that goes behind it. And then other thing I initiated with them, it was my initiation, it's called remote control. So what I found out with them is, if the light goes out on highway, how do we know, right? Somebody has to keep going and inspect it, and Tunpec doesn't have manpower to do that. So what happened is you put the lighting in, and then 2 years later, it doesn't work. The only thing you have to do is change the bulb, but nobody's going out there to do it because nobody knew unless you get the complaint through the proper channel of complaint, and it comes from our governor office to New Jersey Turnpike, saying, hey, intersection 9 has no light, then everybody else can do. So what I initiated with them is remote control lighting. So you sit on your desk, and the light goes out, tells you light goes out. So that was my initiation. I was just talking to Bob 2 days ago, he called me from Turnpike. They were still implementing that thing, but that was my initiation with the Turnpike too. So they need to keep sending out people. So even though it seems really small, I would say engineering is the field that you're going to face different challenge every day. That makes me keep going. I get bored really quick. If I need to sit on desk and think same thing again and again, I'll get bored. But in this job, it's like, it could be people management. It could be, hey, this township don't want to give the land or whatever. It could be something very simple. So the problem solving is the main thing. Yeah.
So can you like go into detail for like some of your, like the design process for like some of your projects?
So it seems like you're interested in New York City Transit, right? So for a signal, let's say that's for a signal, right? We call it throughput and safety. Throughput means how many train you can push it out within 1 minute. That's your, so when the train station get very congested, you want to push out as many as train possible, right? But that how many maximum train, and it all depends upon where you put the signal. Because that signal is governing the movement of the train. If my train trip at that signal, let's say I'm going 60 miles per hour, that's the max speed of my train. If it goes in emergency and it runs the red light, where this train is going to stop, that's the main question. Because you don't want to hit the train in front of you, right? So that's the logic behind it. But to put it in perspective, there's a lot of drawings and curve and braking distance and stuff that we calculated to put that signal at the very specific location that we can put. If you decide I want to put 10 train in a minute, one after another, right? I can push down 10 train in a minute, which is impossible because by the time people load. But that's how we design the signal, and especially the train station like MetLife Stadium, right?
All right, our first session is coming to an end. Thank you so much. Make sure to say thank you on the way out as we wrap up our first session, and you'll be moving to your second session on your sheets.
Thank you very much, guys.
Thank you. Thank you.
Thank you.
Yeah, so you guys, it's a lot of stuff. It's very hard to explain, but it's a lot of stuff. And it's all skill that you develop little by little by working with someone.
You never work alone on these deals. That's why you're able to move, because you
Yeah.
have a team.
Thank you.
Thank you. If you guys have any questions, I'll be around. Thank you very much. How's it going? How's it going? Okay. Did I close the whole thing?
No, it's not gonna hold.
Okay.
If you want to mark up the slide, the screen, do you know how to do that?
Go back all the way?
Do you want to make notes on your slides? I can show you.
No, this.
Hi, how'd it go?
It was excellent.
Good.
I tried. I'm not a
You
professor.
did a great job.
Thank you.